Hello everyone, my name is Arohi and we will understand the significance of optimization in this video. So optimization is a key part of machine learning. So whenever we train any neural network, we define loss function so that we can know the difference between the actual output and the predicted output. So our main goal is to reduce the error and we need optimizers to reduce the error, okay? So without the process of optimization, there would be no learning or development of any algorithm. Alright. So how neural network work? Just see this image. So the first is the data that we start with. It includes example that model can learn from. Each example has an input, for example, a photo and a target output, like the label telling us what is there in that photo. Okay. Then we have model. This is the machine learning or deep learning algorithm that's being trained, okay? And after that, we have this predicted output. So once you train the model, after the model look at the inputs and at this predicted output section over here, the model will make a guess about the output, what should be the output, okay? So this prediction or this guess is what model thinks the correct answer is based on what it has learned so far, okay? Then we have this error or loss function. This part compares the model output, means the model guess or the predicted output, to the actual correct answer, okay? Then the difference between the guess and the correct output, or difference between, you can say, the predicted output and the correct output, is called loss or error. And the goal of our, see, what is our goal over here? The goal of our training a model is to make this error is small as possible. All right. And now comes the role of this optimization method or optimization algorithm. What is this optimization? What are these optimization methods? So this is basically a set of rules or procedures that adjust the model to make its guesses closer to the correct answers. So it uses the information from the error to make the model better. How? Let's discuss that. Okay. So we need optimizer to reduce the error, and we can reduce the error by choosing optimized values of weights, okay? So by choosing the right weight values, our algorithm will give us better results. All right, guys. So now what is the role of this optimizer? So optimizer update the weight parameter to minimize the loss function. All right. So what we are looking for is a certain set of weights with which our neural network can make accurate predictions. And this error function or loss function act as a guide by telling our optimizer if it is moving in a right, direction or not to reach the global minima. Okay. So now what is this global minima? Global minima is just a point where the loss is at the least possible value. All right. Now, yes, there are different types of optimizers, but the goal of every optimizer is same. Okay. So some of the optimizers are gradient descent optimizer, stochastic gradient descent optimizer, mini batch stochastic gradient optimizer, then Adam optimizer, or RMSProp, which is also known as root mean square propagation. Okay. So there are different optimizer, but the role of every optimizer is same. Okay. So today in this lecture, we are not discussing them in detail, but if you want to learn about it, I have a separate video in my channel. This is the video. You can check this video. In this video, I have explained some of the optimizers in detail. I have discussed the math behind it. So you can check that video. Okay. So in Crux, what we have learned, you can say that without optimizers, you cannot make your algorithm learn anything, because without optimizers, you will not be able to update the weights after every epoch. Okay, we'll learn how to use different optimization algorithms. So guys, for that I'm not creating the code from scratch. So this code, the code which is there on my screen, so this Jupyter notebook I have already explained you when I taught you the concept of image classification. So what this code is about, so if you want to classify between daisy and dandelion flower, so we use this image classification algorithm. So we will use this code only, and in this code we will just modify the optimizer part, and we will see how different optimizer works. So let's start. So first we are just importing all the required modules. After that, we have created this simple neural network ourselves, where we have one fully connected layer and then ReLU activation function. Then this is a second fully connected layer, and we have the finer classifier layer where we are using this softmax activation function, right? So this is a simple neural network. Over here, I have defined the transformation which we want to use on our data set. So this class is responsible for our custom data set. So if you want to understand this code, please check the video which is there on image classification. Over there I have explained this whole code. All right, and here we are just loading the training and test data set. Once we load the data, we are initializing, we are creating the instance of our simple neural network model in this model variable, and this is our loss function. So guys, remember in my previous class of optimization, I have told you that error or loss function act as a guide to our optimizer. Okay, so this is that loss function, and after that, these are the different optimizers we want to use. Earlier in my image classification class, we have used this Adam optimizer, okay, with this learning rate. Now what we are doing is, we want to train our model with stochastic gradient descent optimizer, and then we want to train our model with Adam optimizer. Then I am using the RMSProp optimizer. Okay, so this is how you can use these optimizers. So I'm using all these three optimizers in this code. You can pick any one and you can try. Okay, so how to use a stochastic gradient optimizer? Like this. And guys, see, in every optimizer we have defined the learning rate. So what is the significance of this learning rate, how to choose this value, and how this learning rate helps the optimizer to improve the performance of the model. All that code is I have explained all these concepts in my one of my video, the YouTube video, and this is that video. You can check this video and understand. Okay, so here what we are doing is, we are using these three optimizers, and we want to train our algorithm for 50 epochs, and this list is responsible to store the training loss, and this list is responsible to store the validation loss. And then we are using the this loop, and what we want is, we want to train the model 3 times with different optimizer, and that is the code I have written over here. Okay, so I'm not explaining this code, guys. Again, check back the video, the previous video, and from there you can learn what is the function of this code. I'm just showing you the results. See, first training started with the stochastic gradient descent optimizer, and we have trained the model for 50 epochs, and the validation loss for first epoch is this, and training loss is this for the first epoch. Scroll down and let's see, at 50th epoch, this is our training loss and this is our validation loss, and then we have plotted the graph, right? So you can see the training loss, and this orange one is validation loss. So with stochastic gradient descent optimizer, the validation loss is this and the training loss is this. Next one is the result of Adam optimizer. Now after first epoch, this is the validation loss and this is the training loss, and after 50th epoch, 65%, 0.65 is the validation loss and training loss is 0.47. Now let's see, and then we have the graph of it. Okay, now just remember 47 and 65. Let's see the result of previous optimizer. You can see the previous optimizer training loss is 59 and 67, but with Adam optimizer the results are improved, okay, better than the previous one. see, the learning rate is same in all the optimizers. What I'm just trying to show you over here is that with different optimizers you can you will see the result, you will see the difference in the results. Okay, and then we have RMSProp. We have trained our model 50 for 50 epochs using this RMSProp, and after 50 epochs this is the result of RMSProp. See, training loss decreased to 39, and over here we have 65, which is almost similar as the validation loss of Atom Optimizer, and then we are plotting the graphs. Okay, so guys, this is just a basic example and we have only trained our model for 50 epochs. So what you can do is just to understand, just to see the difference, just train the model for more epochs and you can try changing the values of these learning rates and see how the model work. Okay, but always remember that if you are not defining optimizer, then the learning process will not happen in the code, and then there will be, you know, no sense of making the deep learning model if the model is not learning. All right, this code is given in my GitHub link. You can try this code and try changing these parameters and see what kind of difference you get. Okay, so that's it guys. I hope this video is helpful. Thank you for watching.